Hi everybody. This video is going to talk about a couple of things. How to use the binomial probability formula from section 8.1, both on paper and also using the binomial PDF and binomial CDF commands on your calculator. At this point, what I'd like you to do is you'll need get out the following things. You're going to want to turn in your book to page 519 because we're going to look at problem 8.8 called broccoli plants. And you're going to need a pencil and something to write on, and your calculator. If you need to pause the video to get those things, go ahead and do that. And read problem 8.8. Okay, so assuming you've read that problem, let's take a look at it. In that particular problem, we first need to make sure we're in a binomial setting, so let's check all the conditions. First of all, do we have a success or failure? Well, in this case, strangely enough, success is going to be the plant dying. Okay, because that's what we know the probability for. We're going to say that n is 10. We're going to say the probability of success is 0.05. And in this particular case, we're interested in finding the probability that x, our random variable, which is measuring the number of broccoli plants that die, as we want to see what happens, the probability of that being less than or equal to 1. So we're going to calculate two probabilities here. The probability x is 0 and the probability that x is 1, and we're going to add those together. So that's going to be what we're going to do. Okay, so let's take a look at what that would look like. Let's find the probability x is 0. Using the formula, whoops, let me erase that a second, hold on. The probability that x is 0. Well, first of all, we need to take n, which is 10, choose 0 because that's our k in this problem. And then we're going to multiply that by 0.05 to the 0 because we're going to have 0 successes times 0.95 to the 10 because that's going to be all the failures that we're going to have. And we're going to add that to the probability that x is 1. And that particular probability is going to look very similar. We're going to have 10 choose 1, 0.05 to the first power, because remember that's the k, and then we're going to have 0.95 to the 9th. Remember that the exponents add up to n, and the two probabilities add up to 1. So now if you take out your calculator and actually compute these two probabilities, you can type them in order, however you want to look at it. But basically, here's what that's going to end up to. We're going to get a 1 from 10 choose 0 times another 1 from 0.05 to the 0 times 0.95 to the 10. So this is the first thing I'd type in my calculator because everything else is a 1, plus 10, which is what we get from 10 choose 1, times 0.5 to the first power times 0.95 to the 9th power. And when you type that in, however you end up doing it, you're going to get something like this, 0.914 should be the probability that you get, or you're looking at about 91% chance. Okay, so let's say that's what it looks like with the formulas, but what if you're using the calculator? What would you type in? What would that look like? So here's what we'll end up with. If you're going to use the binomial PDF command, which you could do in this case, remember that binomial PDF finds the probability of exactly one outcome. So for example, we could say binomial PDF 10 for n, comma, 0.05 for p, comma, 0 for k. We would need to add that to the similar calculation binomial PDF, for 10, comma, 0.05, comma, 1. If you type that into your calculator, you get the very same thing we got before, which is about 0.914. So that's what it would look like if you could do it, say, in a multiple choice question where you could just type it in. In addition to that, in this case, you could use, since we're trying to find two values, this is a place where you could use the binomial CDF command. And here's what it would look like. You would type in 10 and 0.05 and 1. And what this would mean is it would basically find the probability of exactly one success and the probability of exactly 0 successes added together. And again, it gives you the very same number, very same answer, which is 0.914. 4. And so that is how you would work with the basic formulas from section 8.1.